So we have another interesting question here. A boy runs on a circular path of radius r equal to 28 meter with a constant speed u equal to 4 meter per second. Another boy starts from the center of the path to catch the first boy. The second boy always remains on the radius, connecting the center of the circle and the first boy, and maintains magnitude of its velocity, a constant v equal to 4 meter per second. We have to find how long is the chase. So, using the information given in the question, we can say that the angular speed of the second boy must always be same as that of the first boy. So you see, the second boy has to travel along the radius also and perpendicular to the radius also. So this I am writing as v perpendicular and this I am writing as vr, and we know that the net resultant of these two is v. Okay, so let this distance travel be r. So we can write that v perpendicular upon r is equal to u upon capital R being the radius of the circle. Okay, so now v perpendicular would be vr, since it is a component of v, it can be written as, so that would be okay. Now vr, we can also write it as dr by dt, so that would be equal to now how do we integrate such kind of expression? So you see, we have to use trigonometric substitution. You see, apart from small r on the left hand side, everything else is a constant. So how do we integrate it? We can say that this entire expression u square r square by r square is equal to some v square sine square theta. Okay, so you can remove the squares from everywhere and you can basically just write this. So now if we define it that way and you differentiate both sides, okay, so what do you get? It's equal to v cos theta d theta, isn't it? Now using this, we substitute in the expression, so we would get instead of dr we have to write r by u into v cos theta d theta divided by, now this term inside square root, what should we write that as? You can write it as v cos theta again, isn't it? Because we have defined v sin theta this way, so this expression becomes v cos theta. And let's say that the time of chase is tau, and as you can see in the figure, initially r is 0 and finally it catches up to the other boy, so finally r is capital R. So now using this, we get r by u integral of d theta. Now from where to where does theta vary? So you see, initially since small r is 0, so theta must be 0, and finally if you see the expression, you can say that finally small r is equal to capital R, so you get u into capital R by R is equal to v into sine theta. So that's why final theta you can write as sine inverse of u by v. Okay, so the answer that we get is tau is equal to r by u sine inverse u by v. Putting the values given in the question above, you see u and v both are same, so we can write tau is equal to r is how much? 28. So 28 by u, which is 4, into sine inverse u by v would be pi by 2. Now pi we have been given to use that pi is equal to 22 by 7. So pi by 2 divided by 2. So we get 11 seconds. I sincerely hope you found it interesting. Just keep on checking the channel for more such interesting questions.